So when we're asked to solve a system of equations, what we're trying to find is the set of points with both a value for x and a value for y that is a common solution to both equations, meaning when you substitute those values in and do the computations, you'll get a true statement in each case. Okay, so what I recommend, really your goal is to pick one of the variables and multiply one or more of the equations so that you end up with a positive integer as a coefficient for that for either x or y, and a negative version of that same coefficient for x or y, whichever one you chose. Then you add downward, then solve for the remaining variable, and once you get a value for the remaining variable, you substitute that back into either of the equations and solve for the other variable. So the special cases to be aware of are the no solution case. And what happens when there is no solution? When you add downward, the step where you add the two equations together, you'll get a false statement that is something akin to 5 equals 0. All right. When that happens, when both variables disappear and you get a false statement, it means there's no solution. The infinite solutions case is the other one. And what happens, how you identify you have an infinite number of solutions, is when you add the equations together, you get a true statement that is typically 0 equals 0 with no variables at all. So that's the infinite solutions case. For no solution, I've seen on the AccuPlacer them call it no common solution, so they might use that terminology. But let's get to it and solve this first one. So one strategy, if you're in doubt as to what to multiply both equations by, is to do this. And I think I've showed it to you before. You take this coefficient and you put it there as the multiplier of the first equation. Then you take this coefficient and you put it down there as the multiplier of the second coefficient, and then you change the sign of exactly one of them. Doesn't matter which one, as long as you change the sign of one of them. So I'm going to make the negative 5 to be a positive 5. So now I'm ready to multiply each equation, and you're going to get, for the first one, you're going to get, I'll do it over here, 20x minus 10y equals 30. For the second one, you're going to get negative 20x plus 12y equals negative 20. And then I'm going to add those equations together, and I'm going to get, these are going to drop out. I'm going to get 2y equals 10. So now I solve that equation, so I'm going to divide by 2, and I get y equals 5. So that's the y value of the solution. To find the x value, I need to take that and substitute it back into one of the original equations and solve for x. Now, it doesn't matter which one, as long as you do one of them. So I'm going to do the first one. I get 4x minus 2 times 5 equals 6. Okay, so that would be 4x minus 10 equals 6. I'm going to add 10 to both sides of the equation. I'm going to get 4x equals 16. And now I'm going to divide by 4, and I get x equals 4. Now, that means my solution is 4, 5. Now, if you have the opportunity to guess and check with a system of equations and are given the solutions, the way you would check to see if something really is a solution of a system is to substitute its values into both equations and check to see if you get a true statement. So here, when I put 4 in for x, I get 16 minus, when I put 5 in for y, minus 10 equals 6. Yes, 6 equals 6. Then when I put in the lower equation 4 in for x, I get negative 20 plus 3 times 5, because that's what the y solution is, equals negative 5. So negative 20 plus 15 equals negative 5. Negative 5 equals negative 5. That is correct. So that means I know that I have a solution to the system.